Hello everyone, my name is Vasilina Mikhailova and in today's video I'm going to talk about wave energy. But before starting this topic, I'm going to remind us what waves are and what are some basic wave parameters. A wave is an oscillation that travels through the medium, space or mass, changing the state and transferring the energy. The basic wave parameters are the amplitude, which is half the height difference between a peak and a trough, wavelength, the distance between successive peaks, period, the time between successive peaks, wave speed, the speed at which peaks move, and frequency, which is the number of peaks that pass per second. The following presentation focuses on wave energy as well as its applications in life. The presentation answers the following questions. What is wave energy? How is it produced? How wave energy is measured? Can a person use wave energy? And what are some wave energy devices? Wave energy is the energy carried and transported with the wind waves on the ocean surface. It is an environmentally friendly source of electricity which has been frequently used by humans over the past 2 decades. How is wave energy created and produced? Wave energy is based on the power of the ocean transported with the wind waves. So the main source of the waves is wind. When the wind blows across a smooth water surface, its particles touch the water molecules below and generate the frictional force between the air and the water. Due to the frictional force, the water is caused to move, resulting in small ripples on the top, known as capillary waves. Gradually, the capillary waves will grow into stronger and bigger waves which may travel away from the area they were generated in. The wave energy is the sum of wave kinetic and potential energies, which can be found by this formula, where E is the wave energy in joules, P is the density of water, G is the gravitational acceleration, and A is the amplitude. The intensity of the waves can be measured by the following formula, and it is a scalar quantity that characterizes the power carried by the wave in the direction of its travel. It is determined by wave amplitude, wave speed, water density, and wavelength, and measured in watts per square meters. So it can be found by the following formula, where I is the intensity, P is the density of water, C is the wave speed, and A is the amplitude. Wave energy can be used by people as the source of electricity, and it can be produced when electricity generators are placed on the surface of the ocean. There are some devices that produce wave energy, and I will provide 3 examples. The first example is orbital terminators, which are the large devices that capture the waves. They use potential energy of waves instead of kinetic to generate power. Overtopping terminators look like large, floating reservoirs with ramps and reflectors extending off the end and turbines located at the bottom of the reservoir. How do they work? When waves first approach an overtopping terminator, they bump into its reflectors. Due to their design with angles outward, the reflectors gradually rise in height and compress in width, leading the water all the way up to the reservoir. With the help of the overtopping devices, the waves are finally transferred into the reservoir, located at a height slightly above the sea level, and released back into the ocean next to turbines. The turbines are then coupled to generators to produce energy. The second example is an attenuator, which is a floating structure oriented parallel to the wave direction and effectively riding the waves. These devices have 2 arms that move relatively as waves pass, as shown in figure 4, and these 2 arms capture the energy. A point absorber is the third example, and it is a floating structure which can absorb energy from all directions through its movements near the water surface. It moves up and down as the waves move, as shown in figure 5, and by doing so, the electricity is generated. The intensity of the produced power depends on the resistance between the 2 separate parts of the device, and in order to extract the possible most power, the resistance must be adjusted to achieve maximum energy conversion efficiency. Summarizing the key points of my presentation, wave energy is an essential source of electricity in today's world. The basic wave energy parameters are the density of water, gravitational acceleration, amplitude, wave speed, and the intensity. And the main formulas are the following: overtopping terminators, attenuators, and point absorbers are the examples of wave energy devices used by people. Although there are some wave energy negative impacts on the environment, such as impacts on marine ecosystems and fisheries, wave energy is considered as renewable, green, pollution-free, and environmentally invisible, if not beneficial, energy comparing to other alternate energies. Its net potential is equal to or better than wind, solar, small hydro, and biomass power. What is more, as a result of intensive research and development of new devices, wave energy might be expected to have the most promise for becoming a major energy source in the 21st century. And these are the questions left unanswered, which are what are some types of waves? How does each type of waves change the wave energy? And what are some other advantages and disadvantages of wave energy, which were not mentioned in the conclusion? And those are the sources I've been using. And thank you so much for your attention.